Hello and welcome to the rational root theorem and finding one root video. This is kind of the beginning of our overall plan, which is to find all the roots of a polynomial and write it in factored form. But right now we're just going to practice finding one root. So if we take a look at the steps we're being asked to do, first thing we want to do is state the degree. We practiced that a lot last unit. Remember, it's just in standard form, it's the highest exponent. So in this case, the degree is 4. Next, it states, state the total number of roots or how many roots you could have. Some might be real, some might be complex or imaginary. We can have, as many roots as we have degree. So the total number of roots is 4. So now that we've done parts A and B, which go pretty quickly, let's look at that last part that says use the, where's my highlighter? Use the rational root theorem to find all possible rational roots. So here's the thing, if we're going to spend time trying to find at least one root for this polynomial and write it in a factor, how are we going to know what numbers to try? There's so many numbers out there. Well, the rational root theorem helps us narrow down our scope. So what we do is we take a look at our p-value and our q-value, and we set up our rational root theorem with p over q. Now, p, in this case, is going to be your last term, or constant, so something without an x. In this case, that would be 9. And we're going to put that over q, which is the leading coefficient, or the number out in front. In this case, 1. And then what you're going to do is you're going to list the factors. So everything that goes into those numbers, factors of the numerator. Oops. There we go. Forgot the R. Numerator and denominator. So in our steps, if we were to kind of show down here, we're going to have our possible rational roots. If we do our p over q, it's going to be 9 over 1. And then we're going to go and list all the factors of the numerator and denominator. So all the factors, or everything that goes into 9, is 1, 3, and 9. And everything that goes into 1 is just 1. So now we look at the combination of all of these numbers, all the combinations of the numerator over the denominator. So in this case, some possible roots we can have is x is equal to, we have 1 over 1. We have 3 over 1, which gives us 3. And we have 9 over 1, which gives us 9. So we have some possible roots, rational roots, meaning numbers that we deal with, not anything with I, could be 1, 3, or 9. But a big thing to make sure is don't forget the plus or minus. So I'm going to stick a plus or minus out in front of here, saying, hey, you know, some possible roots we might have is a positive 1, positive 3, and positive 9, or negative 1, negative 3, or negative 9. So this is us using our rational root theorem to create a list of our possible roots. And after we've done that, the next step is to test out some of these roots. So let's go ahead and do that on the very next page. We're going to take a look at problems 1 and 2. So if we were to scroll up, you'll see here it says, use the rational root theorem to generate a list of possible rational roots. You know, beforehand we had 6 possible roots because we had positive negative 1, positive negative 3, positive negative 9. but we can only have a total of 4 roots, so it's not going to be all of those. And we may try all of these, and we may not get to 4 of these because some of these roots, again, might be imaginary or complex, because these are just the possible rational ones, excuse me. So we're going to use our rational root theorem to come up with a possible list of rational roots, and then we're going to practice using that synthetic division to find just one of the actual roots. We'll spend more time next class period on Tuesday working on finding all of the roots, but right now we're just focusing on one. Again, you don't have to find all of them. Choose wisely. Some of this might be guess and check. You might get it on the first try. You might not. We'll talk about that when we come to that. But before we can use that synthetic division, first we have to use our rational root theorem. So if we zoom in on problem number 1 here, and we look at our P over Q, which is just a 1, rational root theorem is going to be P over Q. So for us, that's 8 over 1. So if I go through and I list out all the factors of 8, it's going to be 1, 2, 4, and 8. And the possible factors of 1 are of just 1. So when I'm like, what are some possible rational roots I could have? Well, I can say x is equal to the positive and negative version of 1 over 1, which is 1, 2 over 1, which is 2, 4 over 1, which is 4, and 8 over 1, which is 8. So these are all the possible numbers that I can choose from when I am trying out roots that happen here. So just from teacher knowledge, I'm going to say, you know what, maybe we try a positive 1 first, when x is equal to 1. So I'll set up my synthetic division, and say we have 1 up here in the corner, and I'm going to list out all of my coefficients. So in this case, it'll be 1 for the x cubed. We'll do a 0 for an x squared, a 0 for an x, and then 8 for the constant. So remember, when you're doing synthetic division, please go through and leave your placeholders. So if I choose 1, just a positive 1, remember I bring down the first number. I'm going to multiply this one to this one, bring it down, becomes 1. I'm going to add these two numbers together, and that's 1. Multiply again, 1 times 1 comes down here, that's 1. We get 1 times 1 gives us 1 right here, 8 plus 1 gives us 9. Now here's the problem. Whatever number we get right here, that's a remainder, unless it's 0. We want 0 as our remainder because that means that the number we've chosen goes into our polynomial nicely. It's an actual root. So unless this number is 0 right here, then this didn't work for us. So we tried a positive 1, it didn't work. So you know what, I'm going to erase what we did, and we're going to try through this again. So let's see, let me erase this, erase this. Let's try another one. So this is me just kind of showing you that, yeah, sometimes you may try something and it works, sometimes it doesn't. So if it doesn't work, let's try another one. Let's try -2. So if we try -2, I'm still going to bring down that first 1. I have 1 times -2, that goes right here, which is -2. -2 plus 0 is -2. -2 times -2 is a positive 4. That'll go right here. 0 plus 4 is 4. 4 times -2 is -8. And 8 plus -8 is 0. So we take a look here and we go, okay, so in this case, our remainder is 0. We know that we've done this correctly and that this is an actual factor and goes into it nicely because we don't have a remainder. So if you get a remainder other than 0, try again, but this one seemed to work. So when I write out my root, I'm going to say that x is equal to -2. That's the root that I found. That's what I want you to put in the answer box for the Go formative when we work on this next class period. But again, just a reminder, if the remainder is 0, you found an actual root! Exclamation point, because we're excited. So remember, if the remainder is not 0, try again. So let's try this out just once more. We're going to take a look at problem number 2. So let's see, for problem number 2, when we take a look at our rational root theorem here, we're going to have P as 81 and our Q is 5. So when we do P over Q, it's going to be 81 over 5. And when I list out all these factors, we're going to have a lot more to deal with. So the factors of 81 are 1, 3, 9, 27, and 81. And all of the factors of 5 are 1 and 5. So now we need to go through and come up with as many combinations as we possibly can here. So when I think of what are all of my possible rational roots, I'm going to say x is equal to the positive and negative version of 1 over 1, 3 over 1, 9 over 1, 27 over 1, and 81 over 1. So we're just trying them all over 1. And that gets us 1, 3, 9, 27, and 81. But now we have to do all these numbers over 5. So we'll have 1 over 5, or 1/5. We'll have, 3 over 5, or 3/5. We'll have 9 over 5, 27 over 5, and 81 over 5. So these are all the possible combinations we could have, the positive and negative versions of possible rational roots. Now remember, rational numbers can also be fractions, so we might find that some of these fractions are roots. However, I usually don't want to have to deal with that, so when I start trying out roots, I usually start with my whole numbers first, either positive or negative. So this problem actually has a few different roots that you might possibly find, so I'll do this twice just so you can see what your possible answers might look like. But again, you only need to find one, and I'm just going to let you know they are not the fractions. So we're going to try, again through teacher knowledge, there we go, some roots that we may have. I'm just going to show them both without some of the guess and check, although I do encourage you to try some other possible numbers as well. Feel free to pause the video and try this on your own. But you might find that if you try the root of 3 and you write out all of your coefficients, you'll have 5 for x to the 4th, 0 for x cubed, negative 54 for x squared, 0 for x, and 81 for your coefficient. So again, when you're doing synthetic division, please remember to use those placeholders. But for synthetic division, we're always going to bring down that first number of 5. We'll multiply. So 5 times 3 gives us 15. That'll go right here. And 15 plus 0 gives us 15. So when we multiply through again, 15 times 3 is 45, and that goes right there. When we add negative 54 to 45, we're going to get a negative 9. Negative 9 times 3 goes right there. That's going to be a negative 27. 0 plus negative 27 is negative 27. And then lastly, negative 27 times 3 goes right here. That's going to be a negative 81. 81 plus a negative 81 is 0. And we have 0 as our remainder, which means we have found an actual factor, or an actual root. So we're going to have x is equal to 3 as one of our roots. So that would be what I would put in the answer bank for the go formative. Please make sure you're showing me the work as well. But what if that's not the one you found? You may have found negative 3. So if we write out all of our coefficients again, keeping in mind we need to have those spaces, and we'd bring down the 5. Again, we'll try 5 times negative 3, which is negative 15. Negative 15 plus 0 is negative 15. Negative 15 times negative 3 gives us a positive 45. Let's see, positive 45 plus negative 45 is negative 9. Negative 9 times negative 3 is positive 27. 27 plus 0 is 27. And then lastly, 27 times negative 3 brings us a negative 81. 81 plus a negative 81 gives us 0. So this may be what you tried and found again, that your remainder was 0. So you may have found that x is equal to -3. So some of these problems have multiple answers you can find. I made sure to put all of those in the answer key for the Go formative, but that's kind of what we're doing right now, is we're finding our possible rational roots with our rational root theorem, and then we are guessing and checking with our synthetic division, which hopefully doesn't take too long. So that's what we're practicing for right now. On Tuesday, we're going to practice doing it all at once, finding all of the roots, and putting it in factored form. So let me know if you have any questions, and I look forward to seeing you next class period.